Hello everyone, a new video on the ultrasound physics, and today we'll talk about the persistence. Persistence is also known as frame averaging, temporal averaging, and temporal compound. So what is persistence? Persistence is the continuation of display of some of the previously obtained recent frames. These recent frames, they are digitally merged to the current or the last frame being added. So when display happens, display is the current frame and some of the previous frames. This merging happened in real time, so it means that just before the display. So when you activate persistence, where this persistence is obtained, it's in the scan converter. Scan converter is the last step just before the display. In scan converter, every frame is formed first as an image and then it's sent to the display. But when you hit persistence, what happened? This is the current frame that's been built now. And we have here some of the previous frames that have been saved in the scan converter. You know, scan converter has a memory. So some of these last frames, they will be added digitally. The information, the data in these frames are added to the current frame. So what happens now? I'm getting a frame that is a composite frame, is made of several frames, not only one. Okay, so this is the persistence. So is persistence adjustable? Yes, it is adjustable, and you can have different levels of persistence, like low persistence. For example, you are adding 2 or 3 of the previous frames, or you might have moderate persistence. You might add more than this, like 4 or 5 frames or more to the current frame. Or you might have high persistence when you add more than 7 or 8 frames. So they will be added to the current frame you are having. It means that you are adding a lot of history to the current frame. So what are the advantages of applying persistence? Why we need it sometimes? It adds more signals. So I'm getting here better signal to noise ratio. I'm getting a better quality image, smoother, and I will get a better contrast resolution. It's better to be applied, when we talk about persistence, better to be applied for tissues or organs that have limited or no movement. Example, like when scanning abdomen or small parts, or OBGYN. Okay, if you add it to vascular, if you add persistence to vascular, make sure that you don't add a lot of persistence when you have color. Why? Because it will add a lot of changes that happen in the previous frames, which are not persistently currently in the current frame. So it will add more history, which might confuse the picture of color display. So make sure that when you apply persistence and color, add low persistence. This will help filling of the artery or the vein with color, but don't add a lot of persistence. So what are the limitations of persistence? First is that it will degrade the temporal resolution dramatically. Okay, you will get low frame rate because each frame will take a longer time to form. It's less useful with rapidly moving structures like the heart because each frame is different from the previous ones. If you go to the history, for example, if few fractions of a second, for example, 0.3 or zero point 0.4 of a second, the recorded signals and data are different from the one that you're having now. So you can't add them. Okay. It will not emphasize the data you're having. It will confuse the data you are having on the current frame. Okay. In vascular color, again, we don't apply a lot of persistence. Make sure that the persistence is lower persistence in applying color. So we just explained persistence. What is the difference between persistence and compound imaging, or sometimes called spatial compounding? Okay, to know this difference, we need to know that spatial compounding or compound imaging, you're having different frames from different angles, and they are meshed together so that you can avoid the shadowing or sometimes the oblique angles. You can get a better image from different views. Okay, but in persistence is you're adding images that are from the same angle, the same view, and that will emphasize the picture. In spatial compounding, you get the different frames from different angles, and this will add to the picture to avoid some artifacts like shadow artifacts. Thank you, and see you in another video.